All right. So I just posted the first intuition video, which was about MRS and why we set it equal to price ratio. Um, and I have a little bit of extra time today. So here you're going to be getting intuition video number 2. And this one is going to be regarding everybody's favorite substitution and income effect. Okay. Um, So the reason why we track substitution and income effect is because um, prices change, and when prices change, we demand different combinations, right? So um, you look at maybe a setting in which you're going to the grocery store. You're normally buying two different things. The price of one thing goes up. Maybe you buy less of that good, and then you buy more of the other good. Okay. Um, and this is all stuff that kind of happens, and we're not really aware of it in the real world, but it's stuff that can be tracked, right, through graphing, through, I guess, just pure math, right? And this is stuff that we're going to kind of try to explain today. So let's say that the price of good one increases. Well, there's two different things that are happening here, right? First off, good one is now more expensive than good two relative to what it was before, right? So it might not be more expensive in an absolute sense, right? So say that, um, here we go. Let's try to stick some numbers onto this. Let's say that P1 is originally 2, but now it goes to 4, and let's say that P2 is equal to 6, right? P1, right, good 1, is still cheaper than good 2, but it's more expensive relative to what it was beforehand, right? So this is the whole substitution portion, okay? We want to be able to track how do we change our consumption based off of these price changes. But what you also want to be aware of, right, is that there's an income effect that's going on, right? Say that our income was originally $12, we can no longer buy the same bundle that we had before, right? So let's say, for example, that we had 3 units of good one and we had 1 unit of good two, right? 3 times 2 plus 6 times 1, that equals 12. But now when you try to buy the same bundle, right, this is 3 times 4 plus 6 times 1, it's no longer affordable. It now costs 18. So this is the income portion. So you want to be able to kind of think about each change in price in these two different lights, right? There's the trade-off between two different goods that happened as a result of the price, but there's also the result of a change in purchasing power. And so this is what substitution and income effect tries to um, track, right? Um, and so that was kind of a long-winded explanation. Let's get into how we go about solving these. Okay, so let's take a look, right? And we're gonna be just kind of coming up with numbers on the spot. Let's say that utility of x1 and x2, right, or as a function of them, is equal to, let's say, x, that's wrong. Let's say that it's x1 squared. Actually, you know what? This is going to be a good one. We're actually going to combine substitution and income effect with a quasi-linear problem, okay? So let's say that it's the square root of x1 plus 4x2, right? And I'm coming up with these numbers, and I haven't tutored in a while, so this is, hopefully these numbers work out okay. And let's say that P1 is equal to 2, P2 is also equal to 2, and let's say that M is equal to 8, and let's say that P1, it jumps from $2 to $4, okay? And so we want to be able to first find what the substitution effect is. So what we're going to do, and what I recommend doing, is having a column set up for that, right? And then after that, we're going to find the income effect. And so in order to track this, right, you can come up with this matrix that looks like this. And if you want to have total effect, you can totally do that, but total effect is just the combination of substitution and income effect. So I'll leave it up to you to think about whether or not that's necessary. And a lot of times, actually, I would recommend doing that. And I'll switch the axes just for visual purposes. So x1, x2, substitution effect, income effect, total effect. I do recommend having the total effect because sometimes you'll know the total effect and that'll give you information about potentially what the income effect is or what the substitution effect is. For example, let's say that let's say that the substitution effect for good one is positive, but we know that the total effect for good one is negative. Right? We forcibly must assume that income effect is negative, right? So this is another reason why maybe tracking it, all three of these is kind of cool. Anyway, so let's get back to this problem. As I may have mentioned in some of the lectures that I've posted beforehand, right? It kind of boils down to point A, point B, and point C, right? And these are kind of abstract and they don't directly relate, right? But we know that going from A to B, that's your substitution effect. Going from B to C, that's your income effect. And going from A to C, like that, that's going to be your total effect, okay? So we want to find our bundles at each individual point A, B, and C, and that'll ultimately reveal to us what our individual effects are. Okay, so starting off with point A. Point A is just our original bundle given the prices that we were working with beforehand. Okay, and so we do this pretty easily, right? We see that our MRS in this case, right, is the marginal utility of x1 over the marginal utility of x2, right? So we get 1/2 x1 to the negative 1/2. All of this over 4, right? And we know that this is going to be equal to 1 over 8 times the square root of x1, right? So this is kind of the math behind it. And we also know that, right, because of the fact that we have DMRS, right, as x1 increases, right, my MRS is going to decrease. That's going to allow me to set this equal to our price ratio, which, if you remember, was originally 2 over 2, or we can just write it as 1. Okay, so 8 times the square root of x1, just a little bit of rearranging, so just try to follow along, is going to be equal to 1. So the square root of x1 is going to be equal to 1 over 8, and so it'll be equal to 1 over 64. This is the original amount of x1 that we're going to consume prior to any sort of price changes. So obviously, I kind of messed up. I didn't pick the right numbers, so I apologize, but we're still able to determine our bundle based off of this, right? And so already we know that this is going to be the optimal amount of x1 because of the fact that this is a quasi-linear utility function. So going back to quasi-linear, we know that we can find the optimal amount of whichever variable is in our MRS just by setting it equal to our price ratio. And because this is the optimal amount for x1, we can now solve for x2. So I'm going to do a little bit of board rearrangement here just to kind of clean things up. Right, but we know that P1, right, P1 x1 plus P2 x2 is equal to 8. So we know that P1 is 2, x1, right, was 1 over 64, plus 2x2 equals 8. So 2x2 is going to be equal to, and I'm going to have it as 8 minus 2 over 64. This is going to be some number that's barely below 8, which I'll do for you guys, but it's probably easier to just leave it as a fraction. So 8 times 64, 512. So x2 in this case will be equal to 510 over 64, right? So whatever that number is. So now we found bundle A, or I should say bundle at point A, and it may be helpful to just keep it up here. So 1 over 64, comma 510 over 64, okay? And now you might think, well, let's find point B, right? But for reasons that I've actually already explained in my lecture videos, in which maybe you've already seen through experience, or in your own videos that are posted by the professors, or I guess you're in person at this point, so heard from the professors. Point B is hard to find. What's not hard to find is point C, right? Because we do the same exact process, right, for point C, okay? And so we now are working with different prices. And so we know that our MRS, right, remember our MRS stays the same, is 1 over 8 times the square root of x1, right? Except that now our price ratio is equal to 2, right? 4 over 2. And so we get that 16 square root of x1 is equal to 1. So the square root of x1 is equal to 1 over 16. This is going to be an even smaller number, right? So we're going to square both sides, right? And we get that x1 is going to be equal to 1 over 16 squared. I have that right here. And that's going to be 256. Okay, so we can already write that down here. 1 over 256. We're going to do the same exact thing, right? In which we plug our value of x1 into our price, or our budget constraint, that's the word for it, and we get that 4 times 1 over 256 plus 2x2 is equal to 8, right? Our income doesn't change. And so what we're going to do here, 8, actually, I think I may have messed up on point A. Let me just double check. 2 over 64. Here, 1 second. And this is probably not ideal for a YouTube video, but I just need to double check that I remember to divide by 2. So going back to point A, right, we had x1 was 1 over 64, so 1 over 64 plus 2x2 equals 8. So 8 times 64, 512. So actually I did mess up. And so for those maybe who are keeping track, you probably already noticed, but 2x2 should equal to 510 over 64. And so when you divide by 2, right, 510 over 128. And whatever this is, right, it's not really much of our concern. So this is actually what our bundle should be at point A. So let's try to catch up. Let's go back to point C, right? C, yeah, here we go. C, we have 1 over 256. That's our value for x1. We know that our price, whoops, is 4 times 1 over 256 plus 2x2, right, equals to 8, okay? And so now I want to get 256 in my denominator, so 8 times 256, and Jesus, this is getting to be kind of ridiculous fractions, so I apologize. But what you end up with is 2x2 is equal to 2044 over 256, And so again, you divide through by 2, and you get that x2 in this case is equal to 2044 over 512. Okay? And so 2044 divided by 512. All right? And so let's do point B, right? There's a few rules that will help you find point B, and this is why I recommend finding point A and point C first, right? We know that the utility at A will equal to the utility at B, right? So this is why having point A is important. And the price ratio, that doesn't, I messed up that P. Price ratio at point C is equal to the price ratio at point B, okay? And so we use these two facts in combination, and this is what tells us what bundle B is, right? Because, for example, the utility at A is, and so let's get this in our calculator, plus 4 times, here we go. This is roughly 16.0625. So we now know what utility at B is, okay? Meaning that the bundle at B, when you plug it into our utility function, will have to equal to this. And remember, our price ratio at C is just 2. So why is this important? Well, we know, right, that at point C, or at point B, I mean, and I apologize if my marker looks like it's dying a little. It is. Point B, right, we're still going to have the same MRS, which, if you remember, is 1 over 8 times the square root of x1, right? This is what our MRS is. And what we remember, MRS stays constant throughout, right? We know that the value that it can take on can change based off of the values that we plug in, but the equation itself is staying constant. So we know that this is equal to 2, right? And we know this because the price ratio at point C is the same as the price ratio at point B. And because we're dealing with quasi-linear, we can already determine our optimal value for x1, right? Our optimal value for x1, right, when we set it like this, we get, again, 16, whoops, or bring it down here, right? Remember, 16 times the square root of x1 is equal to 1. So rearrange square root of x1 equals 1 over 16. Square both sides, we get that x1 equals to 1 over 256. Okay, so at point B, x1, right, has the same value as it does at point C. And maybe you'll notice after a few more practice examples, right? But this is basically always going to be true. I don't want to say always because I haven't done this in a while, but I want to say that it'll always, basically always, you'll have the same value in x1, right? Or I guess I should clarify, whichever variable is in your MRS, that's the value that's going to stay constant between point B and point C, okay? And so you might be wondering, well, how do we go about this now, right? And remember, for point B, we can't simply plug it into our budget constraint because of what substitution and income effect is at its heart, right? And we can show it more graphically. But this is where this fact comes in, right? Because if we have what x1 is, right? x1 is 1 over 256, and we have what our utility is equal to, that leaves only one unknown variable, which is x2. And so we can go and plug this in. So 16.0625 is equal to the square root of 1 over 256 plus 4x2. So whichever value this is, 1 divided by 256.5, right? So 16 here is going to be equal to 4x2, and so this will be the only number that actually works out pretty well. And we get that x2 is equal to 4. Okay, and so this tells us, right, the substitution effect from A to B, income effect from B to C, total effect from A to C. And that's how we solve for substitution and income effect. Graphically, what this should look like, and I'm not going to use this utility function because quite frankly, I don't really even know how to draw a quasi-linear utility function. So let's just draw it with Cobb-Douglas because those are the easiest to draw. So here we have it, and it looks like my marker is failing me. So hopefully this is visible in the video, right? I have a feeling it won't be. So this is, right, let's say that this is our original budget constraint, right? And this is point A. And let's say that P1 increases to the point where we now have something like this, right? We know that, right, point C is going to be on this new budget constraint. And let's say, for example, that point C is, here, let me rewrite point A. Point A is here. And let's say, for example, that point C is just right here, okay? We know that point B is going to be on the same indifference curve as point A because they have the same utility, right? But it's also going to have the same slope as point C, right? And the slope at point C is, remember, the new price ratio. And so that tells you that point B will be somewhere here, right? Because this slope is greater, and we know that this has diminishing slope, meaning that the slope to the left of A is greater than right, than to the right of A. Hopefully that made sense. And so this kind of explains the reasoning for why we have those two rules: utility at A equals utility at B, and price ratio at C equals price ratio at B. And it also explains why we can't simply use the budget constraint for point B, and that's because it's not on any of the budget constraints that we've established beforehand. Okay, so I'll leave it at that. Yeah, I guess this video kind of went a little long. It's about half as long as my regular lecture, so I guess it's not so much an intuition, more like a mini lecture. All right, bye guys.